In this session, we will be looking at relationships. Relationships are how we tell Veezoo how the classes within the knowledge graph relate to one another. So let's have a look here at this knowledge graph. We have a bunch of classes, we have customers, we have products, we have orders, and we would already be able to ask questions about these. So we could ask how many customers do we have per segment, or maybe show me all customers with a birthday next week. But if we would like to ask a question, for example, something like which customer have ordered a certain product, we cannot do this right now because there is no connection defined between the product and the customer. So Veezoo does not know yet how to relate these two classes to one another. And this is, of course, where relationships come into play. Technically speaking, on an SQL level, relationships will help Veezoo to form the joins between the underlying tables. Now, the first thing to consider when dealing with relationships is their cardinality. So we can have different types of relationships. If we think about orders and customers, one customer can have many orders, but one order is always placed by one customer. In this case, we would talk about a many-to-one relationship. We can also have one-to-many relationships or one-to-one or many-to-many, and we will talk about some variants of those later. But if we are designing the database, if we are designing a system, we would prefer to always have the relationship on the many side and going to the one side. Now, usually this is given by the tables themselves. So technically speaking, again, the customers table will have a key for the customer, an ID. We call this a primary key. And then on the orders table, we would have a foreign key, which is a reference to the customer. So one line per order, one foreign key of a customer. So we can match each order to exactly one customer. And if we take a look here at the orders class, we can see we have here a class customer. This here is a reference to this customer here. So we would like to exchange this customer class here with a relationship to the customer class we have over here. And we can do this by going into the studio. And then we can see here we have the customer class. Now, what we want to do is define a new relationship. We call it with customer. Now we need to tell the relationship to what it is. So this is going to be with the customer. This is a reference to the other customer class we have defined earlier. And Veezoo suggests the different cardinalities we could choose here. Many to one is a default, and this is also what we're using here, so we don't need to explicitly define it. We need to add an SQL tag, which will tell Veezoo what column to match from this table with the primary key, the SQL tag of our customer table. So we can get rid of this. And now if we go back into the knowledge graph, we can see we now have a relationship defined here. Now we are still lacking some other relations. So each order is made up out of line items, and each line item is for a specific product. And once again, one order can contain many line items, and one product can be part of many line items. So in both cases, we want to have the relationship here. Let's change that as well. So we have the order here. We can get rid of this. And then we also have the product here. So we're going to do a new relationship called with product. We're gonna match it to the product. And once again, we are gonna put the SQL tag there. And now if we save it, we can go back to the knowledge graph, reload it, and we can already see some structure. Now, we can give names to these relationships. So right now, we just know there is some relationship between order and customer, but we can give this a name. And we can do this by looking at the relationship here. Let me move that up a bit. And adding the tag display name. So we will call this here, since the order was placed by the customer, we will call this placed by. Going back into the knowledge graph, we can see here the order was placed by a customer. Now, we can see here in the orders table, we have a recipient. And in this database that we're using here, an order is placed by a customer, but it can be for a different person. So maybe it's a birthday present for someone else, in which case we would record a separate recipient. Our recipient, actually, in this case, is just another foreign key of the customer. So we don't have a separate recipient table. We just use the same table here again. And I added this here to illustrate that you can, in fact, have multiple relationships between classes. So we have the recipient here, and we set up a second relationship. We're gonna call this with recipient. And of course, we're still gonna go to the customer because the class that we're joining with is still the same. So we're gonna still call this to customer, and then we're gonna bring over the SQL once again. Coming back here, we now have two relationships. And we can see that this relationship here is called placed by. And similarly, we could have here a second name called maybe placed for. Now, right now, if I ask to show all orders, we can see here we have two customer columns, and this is most likely a bit confusing. We can see that often we have the same, so this would be the case if the recipient and the customer are the same, but in some cases we can see here these are different, so the customer ordered this product for someone else. But right now here we cannot really differentiate between the two, and this is of course a bit suboptimal. But we can change this by once again going back, looking at this relationship, and adding a new tag. This tag is called the toName. toName defines how this class that the relationship is pointing at should be called in the context of this specific relationship. So I will call this, since we're joining here with recipient, I'm gonna join this here. No, I forgot to delete this earlier. Now we can delete those entities, we don't need them. And now, if I ask the question again, we can now see we still have the two columns, but this column is now called recipient. So let's recap. We have a name on a customer, on the class customer, which is customer. So if I ask for show all customers, it's gonna show all of the entries in that table. We can have a display name, which I've showed here, which gives the name to the relationship itself. We can also reference this when asking questions. And we can have a toName. The toName is a name that overrides the name of the class we are relating to in the context of this specific relationship. So recipient is something we can ask for. We can ask for orders with recipient Alex Grayson, but we can only do this in the context of this relationship. Now, if we take another look here, we are still missing the class promotions. So what are promotions here? Promotions are campaigns by our company to encourage people buying things. And we have many promotions, of course, and each order can contain a promotion. If you use a promo code while ordering something, then we will register this as this order being part of a promotion. Now, since we are a very generous company here, you can use actually multiple promo codes and stack them on top of each other. And of course, each promotion can have multiple orders. So what we have here is an instance of a many-to-many relationship. An order can contain multiple promotions, but a promotion can also contain multiple orders. So what is this here? This here is simply an artifact of the database. Usually, if we have a simple relationship, we can just store for each order, we can store the key of the customer. But in this case here, because one order can have multiple promotions and one promotion can have multiple orders, there's not a clean way to do this if we want to have one row in the table correspond to one entity of either of these. So we have a special promotion table, order promotion table, which just stores all the relationship. This promotion table has two columns. It just has the promotion and the order ID and tells which match to which. So what we could have here is a relationship from order to order promotion, and then a different relationship from order promotion to promotion itself. This would work. But of course, this is rather ugly because this here is not really a business concept we want to have in our knowledge graph. So we would like to hide this class and simply have a many-to-many relationship from order to promotion. We can do this using a special relationship feature called a join. So usually all of these columns that we're using here, they come from the same tables. So this is the table that we import up here. But now we want to use the special join table as well. So what we can do is we can import this table as well. So now we're importing both. Now we can create our relationship. So far the same as before. But now for the relationship, we don't want to use any column within this table here. So first we can define this as a many-to-many relationship. We don't need a comment anymore. What we can do is we can add a join statement. This basically tells Veezoo, do this as an intermediate step. So before you're using this column here to form the actual relationship, perform this join. This is a very technical definition, but it just tells us we should first, before we join orders with promotion, we should first join our orders table with the order promotions table. And then as a second step, once we have included this second table, we can define the relationship with the column of the order promotion table. Now these joins in here, they can be arbitrarily complicated. We can stack multiple of them together. So we could have join the orders to the order promotions table. We could then join the promotions, the order promotions to the promotions table, and the promotions to I don't know, maybe ad campaign or something. So we can get still as complicated in here as we want. We can stack multiple of these together. But in the end, this is then what we will use right now here to join these classes together. So I can now save this. This class here, as I said before, we don't need this anymore, so we can get rid of it. And now if we reload the knowledge graph, we can see we have a relationship from orders to promotions. And now we can ask, what was the promotion with the most orders? And we can see we got here a result. So yeah, this is how you do relationships. Consider the cardinality. Consider which classes you actually want to have in the knowledge graph because they represent something and are not just artifacts of the database structure. You can have multiple relationships. You can give them names. You can name the target of the relationship in different contexts and make life easy like this for your end users.